Hello everybody and welcome to episode 15 of the video series in which we program an entire video game from scratch from beginning to end in the C programming language using very minimal libraries and no engines, just our brains and our fingers and C programming. Before we get started, as usual, let me talk a little bit about some of the questions that I received since the last time. One viewer says, but the Windows timer on a typical i3 or i5 CPU has microsecond resolution, not 15 milliseconds. The NT-set timer resolution function allows to set the period of timer events with 100 nanosecond resolution. Also, the NT query timer resolution returns resolution in 100 nanosecond intervals, so 15 would be 1.5 microseconds. I feel like we have already beaten this horse to death over the past few episodes, and I think we're pretty much done with it. I'll go ahead and open the solution here, the project. And let's see, we left off last time in a situation where, yeah, we're right here. And everything's working fine. We have a steady 60 FPS, and we have a steady low CPU usage of around 1.5 to 2%, which is just fine with me. So if we go to WinMain, and yeah, of course, as we know, we already know NT query timer resolution. It's an undocumented function, and in fact, if we look it up right about here, let's see, NT query timer resolution. This website is actually called undocumented.ntinternals.net. But look how awesome this website is. I love the website design. It's designed like an old school Windows 3.1 or Windows 95 era help file. It's really cool. But anyway, so this is unofficial documentation. This is not documentation from Microsoft. It's an undocumented function that we're using, and yes, it gives us numbers that are in 100 nanosecond units. So if we go down to, and in fact, I don't think I'm even using it anymore. I'm not even using it anymore. Remember, whereas before I was trying to do a thing where we sleep up until the last possible moment where we know that another sleep would have put us beyond our 16,667 microsecond frame target, and I don't even do that anymore, because it turns out it's just like if the timer resolution is sufficiently high, like at its default of 15 milliseconds, you can't afford to sleep at that point. So at that point, there's just like there's no point. But anyway, you can go back an episode or two where I was playing with this, and you'll see that if you take the 100 nanosecond output for current timer and you multiply that by 0.1, then you basically translate that into microseconds. But anyway, I've ditched all that, and we're just going to do this right here, where we're just going to go into our sleeping pattern until we get 75% of the way through the current frame, at which point we're going to begin, we're going to skip the sleep and just stay in a tight loop in order to have that precision. We want our thread to be alert and running at the exact moment that the next frame starts. That's all. Anyway, so yeah, I'm tired of talking about the timer resolution. Next viewer asks, why do Windows.h functions return non-zero values when succeeding, while the main function returns 0 on success? Okay, so the main function, I think he's talking about WinMain, and yeah, WinMain right here. And if this wasn't a Windows application, the function may as well just be called main. I think we went over this in like episode 1 or 2, where I said technically you can name this main function anything you want. You just have to let the compiler know what your quote unquote main function is going to be called. And by default, it has names like main or WinMain if you're programming in Windows. If you're programming a Windows service, it might be called service main, things like this. Anyway, so if you look at the documentation for WinMain, and again, you know, it's just you got to look at the documentation for every function that you use where you care about the return value. You should probably read the documentation for it. All right, so I'm just going to look at WinMain, and I think it's going to tell me in here pretty soon. Return. Yeah, here it is. If the function succeeds terminating when it receives wquit window message, it should return the exit value contained in that message's wparam parameter. If the function terminates before entering the message loop, it should return 0. So that's basically why all throughout this WinMain, if any of my stuff fails, like at the very, if I go to the very end of WinMain here, which is right here, like I'm returning 0 in all cases, no matter what happens. And that's not exactly what the documentation just told me that I should do. But at this particular moment, I don't care. You know, I haven't actually thought of any. I haven't really thought of any sort of situation where I would care. I may change that later, but for right now, I'm just going to return 0 at all times. And the documentation for WinMain says that if you fail somewhere in your initialization, if WinMain were to fail, like if any of these things fail, before you've gotten into your main message loop, then you actually should return 0. So all this stuff is fine. But to answer the guy's question, it all depends on who wrote the function and what the function is designed to return. Some functions return 0 whenever they succeed, but you may have other functions that are like a Boolean type that's like, here I'll just write it like this, like bool try something, you know, and it may take it on, you know, and then so you call it like this, right? And in that case, it may actually, since it returns, the function returns a Boolean data type, or it returns basically a true or false value. It could actually return 0 in the situation where the function fails. Or the function can return anything else. The function might return a pointer to something else. It might return, you know, who knows? It can return all sorts of things. It may not even return an error code. It all depends on who wrote the function and what it was designed to do. So, like even within Windows, even within the Windows operating system, different teams in Windows may design their API differently, so that you have different components within Windows where they all behave differently. All the functions have different, you know, they have different like idioms and different ways of like calling them and different ways of writing them, and they return different things, different types of status codes. You know, it may return an H result, or it may return an L result, or it may return, you know, who knows. The only safe, you can never take it for granted in the C programming language. So the only safe way to play is to look up the documentation for every function you call, as long as you care about the return value of that function. So hopefully that makes sense. Next viewer says, why is the size different from the size on disk? And let me show you what he was talking about. If I go to my source code and I go to assets. Remember last time we started talking about bitmaps, and I pulled up this properties page right here, and we noted that the file, the bitmap file, is 1078 bytes exactly. However, the file takes up 4 kilobytes on disk, and essentially that's just because he wants to know why these two numbers are different. And coming from I don't know if like all file systems work this way. I presume that they probably kind of do, but speaking for NTFS, I can definitely say that it's because of the sector size of the disk. The disk, the hard disk. I have an SSD, but regular spinning disks are like this as well. They use sector sizes, and the sector is the basically atomic unit of storage on the disk, and the sectors on most modern hard drives or SSDs is 4K, 4 kilobytes. So no matter how small the file is, it's going to take up at least one sector. So if you think about that, the uh, if you store a million, millions of tiny little files, you're going to end up wasting a lot more space on your hard drive than if you stored fewer, larger files. It's just the way file systems work. Like I said, I think that they all roughly work like that, that they all probably use sector sizes in the same way, as far as I know. But anyway, that explains the difference. Let's see. Next viewer says, I'm guessing fonts would be implemented in the same way? Question mark. And the answer is yes. We will be implementing fonts, and I think we will be doing it pretty shortly in the same way that we are loading the bitmaps now. I don't want to get too far ahead of myself because we haven't actually loaded a bitmap yet, but when we do, fonts are coming up really soon after that. Basically, I'm going to do a font sheet, that you design your own font, you make it into a bitmap, and then we load that bitmap in our game. We slice it up into pieces so that we can basically print each letter one at a time, and we string them together to make strings, and then we can basically cut out all of this text out junk that we have in render frame graphics. Remember, if I go to render frame graphics, all of my debug HUD, my debug text is all this stuff right here, and I don't like it because it's very slow. It uses GDI, and first of all, I don't like to rely on GDI because it's not portable, and someday we may want to make a Unix version of this game or Linux version. We may want to make a version of this game that runs on an ARM processor on a Raspberry Pi or something. We may want to run this game on a, who knows what. But not all platforms have GDI, so if I want to run it on anything except Windows, I really want to keep my usage of GDI to an absolute minimum. And that's not the only reason I want to keep my use of GDI to an absolute minimum, but that's a big one. Secondly, something that I remember a while back, I was complaining. I've been complaining a lot about how if I run this game, speaking of this debug text flickers a lot, and the reason why is because I wasn't following my own advice. I remember several episodes. I told you that in Windows graphics programming, in Windows GDI programming, you're never supposed to draw to your screen device context more than once. Essentially, you should be drawing everything. Like when I'm doing all these text out calls, I should be doing this drawing not to our screen device context. I shouldn't be drawing it directly to the screen. I should be drawing it to our back buffer, making a device context out of our back buffer somehow, and then drawing to that first, and then basically just blitting the whole thing, here with one single call. So I wasn't following my own advice, and that's why I'm getting the flicker. But I'm not going to fix it because, as I said before, we are so close to implementing our own text drawing routines, and then I could just delete all of this stuff and clear out all of this text out stuff. And all right, so where were we? We were, I think that might be the end of our questions. Except one other viewer says he wasn't able to use Process Explorer with admin rights to kill the process. I was able to kill the purple window by moving Visual Studio over to another monitor with the Windows key plus arrow keys, then pressing the stop button. I think that was several episodes ago. He actually left that comment on episode 7, and that was, I think, before we moved our window to when we were first starting with our window, we made it topmost window, so it would be always on top, and you couldn't switch, you couldn't alt tab to any other window, you couldn't get any other window to appear on top of our game window, and we didn't like that, and we changed it to, let's go to create main game window. Let's see if we can find somewhere in here. There is a top. There it is. In set window position. So this is HWin top, so our game will appear on top of every other window, but you can still drag other windows on top of our game window if you want to. Now earlier I had this set to HWin topmost, which means that no matter how hard you try, our game window will stay on top, and you can't get any other window to appear on top of it in terms of Z order, and that really bit us whenever we crashed our game, and our game was stuck in this crashed state where the debugger was in the background, but we couldn't see the debugger because our game window was stuck on top of the Z order, and we couldn't, yeah, it was terrible. So if you have a secondary monitor, you can get around that, but it wasn't good. That's why we changed it to HWin top instead of topmost. So, okay, that's the end of the questions. Now, let's get back to what we were doing, which is we need to load this bitmap users source assets. We now, if you didn't finish the last episode, you should go back and watch it, because we actually had to install a plugin for paint.net in order to be able to work with 32-bit bitmaps, and I need to correct this file type association issue. There we go. Yeah, so here is this is a 32-bit bitmap, and we also need to keep the bitmap file format. We need to keep that reference open. Bitmap file format. It's on Wikipedia. No. Okay. So, where do we get started? What I think we should do is make a new function. And we are going to call this function, I'm going to start with a D word, and I'm going to call it Load32BppBitmapFromFile 32-bit per pixel bitmap from file. And as arguments, I'm going to take a file name, and then I'm also going to take a pointer to a game bitmap. think that looks good. So notice I'm using my source code annotation language, and I'm telling the compiler that this parameter, by virtue of me decorating it with this in-out keyword, or if you can call it a keyword, call it a decoration, or call it a something, I don't know. But anyway, I'm telling the compiler, hey, this parameter, I'm going to pass this parameter into this function, but this function is going to modify this parameter. And this is very common, as a very common pattern in C programming, where you provide your own buffer. You bring you bring a buffer to a function. The function fills it out for you and then returns. So you know, different functions may say, you know, you need to allocate your own memory first. Some other functions may say, don't worry about allocating your own memory. Your memory will be allocated inside of the function for you. So, you know, some functions will even have a flag that says you can put in a flag that says, you know, allocate the memory for me. Like, you know, if I could do that too if I wanted to. In pool allocate memory. So like I want the user to pass in a flag that says, should I allocate the memory inside the function, or has the user already allocated the memory beforehand before calling this function? Could totally do something like that if we wanted to, but I don't think I want to. So I'm just going to leave, I'm going to take that signature just like that. And the reason why I chose for this function to return a D word is because, make sure I'm actually recording, the reason why I wanted this function to return a D word is I basically made the choice arbitrarily. It's an educated guess. When you are writing functions, well, I don't know how everyone else does it, but when I'm writing functions, I usually want this function to return something that matches the sort of error codes that I'm going to be, that I could potentially be generating in this function. For example, the reason I chose dword is because I know that in this function I'm going to be using create file, for example. Create file is the function that you use in Windows to both create files and open files. But if I go to the documentation, it says, well, it says create file returns a handle, but it also says if it fails, if we go to return value, to get, it says if the function fails, then I should call getLastError, and getLastError returns a dword. So I want to be able to, you know, I want to be able to pass the specific error back to the caller without any loss of information. I'll show you what I mean. Let me go ahead and create this function over here in main.c, and I think it goes. It doesn't matter if your functions are in order. You can put them in any order you want. Like sometimes for neatness and tidiness, and I'll probably go back through and tidy this up later. But like your function declarations in your .h file do not have to be in the same order in which they appear in your .c file. But being a neat freak, I do prefer that they do. So I try to put them in the same order if I can. But okay, so anyway, I've made the Load32BppBitmapFromFile function here. It takes in a pointer to a string, which is the file name that we will be loading from disk, and then it is going to take a pointer to a game bitmap, and it's going to fill that game bitmap. It's going to populate that game bitmap with the contents of the bitmap that we loaded from file. But what I was saying earlier is this, like dword error equals error success. And like I said, everybody programs a little bit differently, but all my functions almost always look like this, where the first line is going to be the error code that we're going to return from this function, and it's practically always going to match the same exact data type that the function itself returns, so that when you get to the end of the function, you're going to return error no matter what it was. Now it's set to error success, which is 0 right now. So assuming nothing goes wrong, I'm going to return 0. But a whole lot of things could go wrong in between here and there. So let's see, what else? I was going to write a label here that I'll probably just call exit. And so this right here is what almost all of my functions end up looking like. And as I've said before, it's usually better to just write simple, non-clever code. When you start getting clever, you make code that is flimsy and non-reliable and difficult to debug. So just write boring code. Okay, so here we are. Now what? Okay, I want to load this picture right here, which is our hero, and he is in just a straight down standing pose. Like, he's not walking, he's just standing straight down. So what I think I'm going to do is, and you might have to bear with me here because I think I'm going to take a leap here, and I'm going to go to our player data structure, and maybe I don't know if I should rename it hero player. I don't know. Maybe I'll call it hero. Let's see. Could we have a player that's not a hero? I don't know. It's not worth thinking about. Let's go, and he needs game bitmap. He needs to contain a bitmap called a sprite. Now the problem is that our hero is going to have many sprites, right? Like I showed you this picture last time, where actually that's not a good one. The one I actually wanted to show you was this one. Yeah, these are all the sprites that our hero is going to have. At the beginning of the game, he's going to have these, this set of 12 right here. And then somewhere in the middle stages of the game, he's going to be upgraded to this middle set of sprites as he finds some leather armor or something. And then towards the end of the game, when he finds some really strong metal armor, towards the end of the game, he's going to look like that. But anyway, so this is just one sprite right here, but we're going to need to have all these sprites loaded, right? Because you can walk in any direction at any time, and it doesn't sound very smart to me to load a sprite from disk every single time your guy changes directions. So I think we should load them all ahead of time. So we have 3 sets of armor and 12 sprites per set of armor. So I think I could do something like this, where I have 3 sets of armor, and then I'm making a 2-dimensional array here. So let's see. I think that's correct, isn't it? Okay, 1 second. Go over here, change this from player to hero, and does that compile? Yeah, it compiles fine. So I don't know, Visual Studio likes to show you errors for no reason sometimes, but yeah, that's perfectly valid. So the idea here is that I'm making a two-dimensional array of sprites within our hero data structure. He has 3 different appearances, and then he has 12 sprites, 12 individual sprites for each appearance. So now what we need to do is, I think if we go up here and I'm just trying to figure out how I should organize these pound defines. Hero suit 0 will be 0. We'll define that as 0. Define hero suit 1 as 1, and define hero suit 2 as 2. Okay, now I need to define I'm going to I'm debating on whether I should take the hero part out of this, because I'm going to have a lot of other characters in this game that are not the hero, right? And those characters may also have suits of armor. They may also have different appearances. So I think we'll just do suit 0, suit 1, and suit 2. Now we're going to do standing facing down. Okay, standing facing down will be 0. So essentially, if you think about our two-dimensional array here, this is going to be right here. This is going to be 0, 0, and this will be 0 and 1. Oh, and 0 and 1, like that. This will be 0 and 2, like that. This will be 0 and 3, like that. And then if we switch to another suit of armor, this will become 1, 0, 1, 1, 1, 2, and then this over here will be 2, 0, 2, 1, so forth and so on. Does that all make sense? Okay, so let me undo all of those things. Alright, so standing facing down. Maybe I should just do down. Standing down is 0. Fine. Walking down 1. Walking down 2. And these definitions are going to come in very handy later on when we want to do animation. We're going to have to do walking animations, right? So not every frame, but maybe he's going to have to, his footsteps are going to have to move like, I don't know, twice a second or maybe 3 times a second or something like this. We'll just have to play with it until it looks right. But let's see, how many animations does he have here? So this will be standing down. This will be walking down 1. That looks the exact same as standing, doesn't it? So, yeah, that actually can be omitted because that just is back to standing. And then this is walking down 2, this guy down here. So he doesn't have 12 sprites per. He has 1, 2, 3, 4, 5, 6, 7, 8, 9 sprites per suit. So let's go back down here and change that. It's to 3 suits of armor and 9 sprites per suit of armor. Fine, walking left 1 will be 3. Walking left 2 will be 4. Walking right 1 will be 5. Walking right 2 will be 6. And then upwards. Walking upward 7. Okay, that is not right. Let me think about this again. How about we just do this? Instead of differentiating between standing and walking, how about we just do facing down 0, and facing down 1, facing down 2, facing left 0, facing left 1. Whoops. Oh, I messed that all up. Oh, God. Okay, let's try this again. Facing down 0, 1, 2, 0, 1, 2. Radius 3, 4, and 5. Then we have a facing right 0. Starts with 6. Facing right 1, 7. Facing right 2 is 8. But where's upwards? Oh, I was wrong. I'm wrong again. So the situation is that I actually am going to have looks like 12 sprites. It's just that here only 9 of them are drawn because he's only facing left here. He needs to be flipped around to be facing to the right. So, oops, my bad. So that's 12 sprites in total. So I had it right the first time. That should actually be 12 right there. Okay. So somewhere we're going to have to start we're going to have to initialize our player, and I haven't really done this yet, but we're going to do gPlayer.sprite. And which sprite are we going to assign? We're going to assign suit 0. And how do we name this? Facing down 0, which is going to be his standing pose. And it needs to be equal to that is not what I want. Here's what I want. Load32BppBitmapFromFile. And we're going to call this file assets. And it's called, so it's going to start from the working directory of this game, so I'm going to have to keep that in mind. It's actually going to have to be something like that to show that so if we're running from this directory right here, then we go up one directory, we go up another directory, and then we go into the assets folder and we find this file right here. Bingo. And the reason why remember I have to use 2 backslashes here because the backslash is an escape character. So to escape an escape character, you have to do 2 of them in a row. And okay, so there's that. And then the next parameter is, remember, it wants a pointer to a game bitmap. So bam. In there. And at the end of the day, do we have an error? You know what? I'm going to just go ahead and make it. I'm going to go ahead and do it right now. I'm going to initialize hero. All right. That goes right after the load bitmap function. So it goes right here. I don't know why it would underline that as an error, but it doesn't matter. Okay, and then up here we're going to go if initialize player or initialize hero is not error success, then we are going to complain and not run our game. Go to exit. Failed to initialize hero. That probably won't stand. Going to end up changing that, but for now, that's fine. Basically, I just wanted to make that into its own function so it didn't muddy up our WinMain, because I don't think this really all needs to be stuck in WinMain. So everything that relates to the initialization of our hero, I'm going to put right here. Okay, we're good. So, okay, so next we are doing a load error equals load 32-bit BPB bitmap from file. And I don't know if I've ever shown you guys this, but you can actually do assignment and comparison in the same if statement. So I can assign the result of this function to the error variable, and in the exact same line I can say if that result, which is now stored in the error variable, does not equal error success, then I can complain about it. And what I want to do is I'll probably want to do like a, not a get last error, because we'll do a get last error in the function itself. But yeah, I'll probably want to complain about it at some point and then go to exit. Let me find another. And basically all this is doing right now is I keep using these message boxes, which I don't even want to use. This just goes to show that it's becoming more and more pressing that I create our own error handling sort of function that does the logging and the error recording stuff that we want to do. It's becoming more and more important as the project gets bigger, so I'm definitely going to have to get on that soon. But anyway, so back here in initialize hero, I'm doing a low. I'm going to just say that this function failed. And I think what this is going to end up causing is sort of a cascade of error modal dialog boxes, where it's like that if this were to actually fail, then the user would get a little pop-up that said load 32-bit bitmap failed, and then they would click OK, and then that error would cascade to the calling function. The calling function would go initialize hero failed. Error user would click OK again, and then at the end of clicking all of these OK buttons on these modal dialog boxes, then the game would crash or stop running. But at this point, I don't really care. I mean, I don't intend for any of this stuff to fail, and if any of this stuff does fail, the game should absolutely crash. So, I mean, because you can't play if any of these things fail. So, we're just kind of assuming that it's not going to fail at this point. But anyway, so our function is properly formatted. So what we need to do is we need to finish our load 32-bit bitmap from file. And to do that, I need... Okay, first thing I need to do is I need to do a create file. Create file A. Create file exa. No? Create file A. Okay, the file name, which we already have. The desired access, which is going to be read-only access. This is one of the... Create file is a very big, complicated function that has tons of parameters, so it's very important that we have the documentation up to look at. Okay, the desired access will be, I think if you go in there and read it, you'll figure it out, but it's something like generic read is what we need. Share mode will be something like share mode read or something. I hate not having this stuff memorized. Yeah, there's generic read for desired access, and then the share mode is like, oh, here it is, file share read. It's basically just saying that I don't want to have an exclusive lock on this file. I want to let other programs read it too. File share read. A good example would be like if I opened a text file with exclusive access and didn't allow anyone to share it, then another user on the system or any other process on the system would try to open that file and it would say access denied because I already had it open. But by opening it with file sharing turned on, it allows other people to basically have simultaneous access to the file. So it's just, being a good citizen, you know. All right, security attributes. This parameter can be null, which I want it to be because I don't want to mess with security attributes of the file. DUW creation disposition. This basically is a D word that tells you whether the file was created or whether it was created or whether it was opened, or like how we want this function to behave. You can call create file in such a way that if the file does not exist, then the call to create file will actually create that file if it does not exist. Sorry, my nose is itching. My apologies. You can also call create file in such a way that if the file does not exist, then create file will return an error. And that's what we want, because it doesn't make any sense to create the file if it doesn't exist, because we need these bitmaps that we're loading to be present. Open existing says opens a file only if it exists. If the specified file does not exist, the function fails and last error is set to file not found. That sounds like what we want. So open existing. And then flags and attributes, I think is like file mode normal or something. File normal. I don't remember. Flags and attributes. File attribute normal. It's basically just a way of opening things like encrypted files or compressed files. We're just telling it, hey, this is just a normal file. And then template file is null. All right, so that is the function, and error equals, okay, so we're going to do if error equals create file does not equal error success. That is not what I wanted. Or actually, no, that's not correct. I think if I read the documentation, it will say if the function fails, the return value is invalid handle value. So that's what we need to do. If error, okay, so if create file results in invalid handle value, then we are going to error equals, we're going to call get last error, and then we're going to return that to the caller. Last error, go to exit. Now, assuming that your call to create file has succeeded, that means that I'm still messing up here. The return value is actually an open handle to this. So I need to actually create a handle file handle equals invalid file handle. Invalid file handle. Wait, invalid handle value. There we go. If you hover over that, it's actually like -1, I think. But anyway, so no, this create file does not return an error code, so we should not be doing that. We should be assigning our file handle value to it. So our file handle is initialized to invalid handle value, and then we are then reassigning file handle to the return of create file, and if create file returns invalid handle value, then we call get last error, store it in the error local variable, go to exit, and we're done. Now, assuming that we succeeded, we'll be right here, and we will have an open handle to a file, the file that we just called create file on. So what we need to do is we need to go down here into our exit, and we need to say if file handle is not invalid handle value, then we should close it. Always remember to close the file when you're done with it. File. And I feel like the compiler is going to complain if it's going to complain that file handle could be null, even though, given the code that we have just written, there is no possible way that file handle could be null. But the compiler doesn't know that, because at this particular moment we are smarter than the compiler. But let's give it a try. So if file handle, we're basically saying if file handle is not null and file handle does not equal invalid handle value, then attempt to close the file handle using the close handle function. All right, let's run that and see what happens. Load 32 bit per pixel bitmap from file failed. Failed to initialize hero. All right, we got to look and see what it looks like when it crashes. So what did we do wrong? If I set a breakpoint right here and step in, here is our file handle variable. It's set to -1 right now. Our file name is hero, all that stuff. This is going to return, yeah, it still returns invalid handle value, and get last error was 3, which is probably path not found. And it's basically because of this. It's because I have the path wrong somewhere in here. I can go ahead and stop it. Let's go to initialize hero. Basically, this is wrong. Wrong. I mean, I could put the fully qualified path to it in there, but I don't really want to. But just to make it work, I guess we will. So for now, we're going to use a fully qualified path name. Let's see if it works now. Get rid of my breakpoint. Yeah, it works fine. Okay, so it was an issue of us just not having the path set correctly. We'll get around to fixing that. I want to plow forward with this. So now that we have the file open, we can now proceed to read from it. Let me go down here. Okay. Let's make a word value, which is going to be called the bitmap header. I can't type. Equals 0. And a word is simply the same thing as an unsigned short, which is 16 bits. And then let's do a dword for pixel data offset. Initialize that to 0. Okay, so let's see. I want to read the first 2 bytes of this file. So I feel like there is a function called readFileEx, which takes a file handle, which we now have open. We have a buffer, which I think we can store this right into our bitmap header variable. Dword number of bytes to read, which this one is kind of weird because this needs to be, this is like a, this parameter needs to be, it's like an in-out parameter. It's like a parameter that is both, you need to tell it that we want to read 2 bytes from this file, right? We want to read the first 2 bytes of this file because, as we showed last time, the first 2 bytes of this file, which if I, well, yeah, let me open it in HXD again, which we did from last time. But if I take this bitmap, load it into HXD, you can see the first 2 bytes of this file are BM, stands for bitmap. We need to make sure that we are reading the correct type of file. So that's the first thing I'm going to do, is read the first 2 bytes of this file and verify that the first 2 bytes of this file are in fact BM. Because if they're not, then we are reading the wrong type of file, and this function will fail. But I can't just tell read file that I want to read 2 bytes because it wants a dword number of bytes to read equals 2. Because if you look at it, it actually wants a pointer to number of bytes to read. And what happens is that when read file returns, it's actually going to replace this number with the number of bytes that it actually did read. So if we asked read file to read 2 bytes, but it actually could only read 1 byte from the file for whatever reason, like say maybe the file was really only 1 byte long, or if we were at the very end of the file and there's only 1 byte left until the end of the file, then it would actually return 1. But it needs to initially, this variable needs to be initialized with the number of bytes that you want to read. Okay, so overlapped I think can be 0, because we're not doing, this is going to be a synchronous read. We're not doing an overlapped read. Overlapped is where it basically enables you to do asynchronous reads from the file system, where basically you can register a completion routine and the operating system will call you back later when your file read is complete. It's actually very efficient in terms of disk throughput, but for our purposes, it's completely unnecessary. We're just going to do just a straightforward, serialized, synchronous read. So I think both of these things can be null. And to verify that, I'm going to look at the documentation. Okay, it takes a handle to the file, we know that. The number of bytes to be read. The buffer that receives the data. If the function succeeds, the return value is non-zero. So if read file equals 0, that means that it failed. And if it succeeded, then we should have a if bitmap header. I messed that all up. If bitmap header equals, or I should say if bitmap header does not equal 0x4d42, which 4d42 is BM backwards. 42, 4d. But because of byte order, the way it's going to look in memory is going to be backwards like that. And in this case, we don't have get last error is not going to contain anything because we haven't called an API function. So we're going to have to make up our own error code here, which is going to be error invalid. I basically just kind of look for an error code that kind of matches. File corrupt, maybe. Error file invalid. There we go. Go to exit. All right, let's set a breakpoint here and run it and see what happens. We didn't get there. We crashed on read file. Okay. All right, I think we should actually start using read file instead of read file ex because it says for a similar function designed solely for asynchronous operation, which is what we don't want, then use read file x. But we're going to use read file. All right, and it says pointer to the buffer, the maximum number of bytes to read. I may actually have been completely mistaken on this. I may actually be thinking of registry functions that have this sort of in-out bytes read sort of thing and not read file, but I'm not sure. All right, there's the buffer, bytes to read, 2 bytes. Oh, here we go. The function is totally different. Read file and read file ex, completely different functions. Number of bytes to read is 2. There we go. Pointer to a D word, number of bytes read. So I did have it wrong. I was wrong. Number of. So this is not number of bytes to read. This is number of bytes read. And let's see what happens. Let's see what happens now. Okay, this time we didn't crash. And our bitmap header is, let me turn this hexadecimal. Our bitmap header is in fact 4D42. So that's correct. You all right?
I hurt my foot.
Did you stub your toe?
Yeah, really hard.
Okay, let's see. We may be going over time here, but we're so close. We're so close. Okay, so we're reading the file. We have the correct header. We basically want to do, okay, so 10 bytes into the file. 10 bytes into the file, we should have a byte offset of where the actual pixel data starts. So, yes, exactly. If we look right here on the Wikipedia article, it says 10 bytes into the file. We have 4 bytes that indicate where the bitmap image data pixel array can be found. So that's what we need to do. Okay, let's see if we can do this. I need to move my cursor So when you're reading a file using create file and read file, it leaves basically a cursor, a position of where you were in that file. So for instance, if I call read file again, it's going to start reading at byte number 3 because that's where we left off. But what we need to do is we need to skip ahead to byte 0xa or byte number 10. So I think it's set file cursor. No? Let me look it up. Set file cursor Win32. Set file pointer. Okay. The low order, assign value, specify the number of bytes to move the file pointer. Okay. I think we do set file pointer, our file handle, of course, and then the distance to move. I think we want to move 8 because we're already at position number 2. So I think if we move 8 more, we'll be 10 bytes into the file. This might take some trial and error. Oh, dword move method. That might be how we can know for sure. The starting point for the file pointer move. Oh, okay. So see, you can actually specify whether you want to start from the current file position, or if you want to move backwards from the end of the file, or if you want to move forwards from the beginning of the file. So let's just do that. And we're going to move in 10 bytes from the beginning of the file. And of course, it says the return value. If the function succeeds and distance to move high is null, the return value is the low order dword of the new file pointer. If the function returns value other than, if the function returns a value other than invalid set file pointer, the call succeeded. You do not need to call getLastError. If the function fails, the return value is invalid set file pointer. Okay. If set file pointer equals invalid set file pointer, then getLastError and go to exit. Okay, now we should be able to read this into pixel data offset. It's a dword, it's 4 bytes, lines up perfectly. So if read file, file handle, pixel data offset, number of bytes to read 4, or if you want to be fancy, you could do size of dword, same thing. And then store number of bytes read. We'll reuse the variable from last time, number of bytes read, and then we don't need to do any of this overlap stuff. Okay. Error equals getLastError, go to exit. Okay. How are we going to find out if that's valid or not? Let me go ahead and just play that through. Now, it says pixel data offset is at hex 36. So if I look, where is hex 36? hex 36. So basically it's telling me that the actual pixel data starts right here. And I am inclined to believe what I see, because if you look at the bytes, they sort of change right here. It's as if the structure sort of changes as soon as you hit byte hex 36. See where we had all these nulls here, null, 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 and then all of a sudden at 36 we get boom f f f f f f 0 0. So this would be like so I think every one of these groups of 4 bytes is a pixel. Starting from where? At the top left. So if I do the color picker and I pick that color, haha, okay, it's actually full red, full green, full blue, but 0 alpha. That's how we get this transparent color. So if I go back to our hex editor, there it is, BGRA. So this is, I think it's still in BGRA format. So this is probably full blue, full green, full red, and then 0 alpha. So it's transparent. That's awesome. Okay, so I think that part works fine. Let's keep going. We need to set our file pointer again because 0xe bytes into the file. There should be an actual bitmap header info data structure in here. Bitmap info header. Size is 40 bytes. It's at, there it is. I think that's what it means. Windows bitmap info header at offset 0xe. Okay, so let's move there. I'll just copy this, paste it here. We'll go to 0xe. E0xe bytes from the beginning of the file. And then we're going to read a 40 byte, there should be here a 40 byte bitmap info header, which is going to be interesting. Read file, file handle, and where are we going to store this? We're going to store this in somewhere in here, aren't we? We're going to store it in our game bitmap .bitmap info, right? Maybe? Game bitmap. Bitmap info and bitmap info header are two totally different things, though. That's what concerns me. So I think what we actually want to do, so bitmap info contains within it a bitmap info header. So I think what we actually want to do is game bitmap info dot BMI header. That should store it into the right place. And then what are we doing? Handle, buffer, number of bytes to read will be the size of a bitmap info header. And then the actual number of bytes read will be, we're going to reuse our variable, number of bytes read, and then doesn't need to be overlapped. And as usual, we will check to see that this call to read file did not result in an error. Okay. Let's see, run it and see what happens. We didn't crash. That's nice. Okay, here's our game bitmap. And let me turn off hexadecimal. So this, it looks like this worked properly because when I look at the bitmap info and I look at the bitmap info header data structure embedded within the bitmap info data structure, and I look at the values that just got populated from the file, we have size of 40, which is the size of the bitmap info structure, not the size of the bitmap. We have a width and a height of 16, which we know is correct. We have a bit count of 32, which we know is correct. We have a size image of 1024. Yeah, I think this is perfect. I think this is perfect. So we just read our bitmap info header, and then finally, let's see, 0x22 bytes into the file. Inside the bitmap info header, we should have the exact length of the pixel data, which we do, which is that BI size image guy right there. So what we're going to do at this point is we have to allocate some memory, because we can't just get see this BI size image is 1024. We can't just pull 1024 bytes of memory out of thin air. We have to allocate it. So, and we're going to allocate it using heap alloc. And the heap is going to be get process heap. And the flags is going to be heap 0. And then the number of bytes is going to be game bitmap. I don't know why it's showing it down there, but whatever. Bitmap info dot BMI header dot BI size image. BI size image. Right there. So we're allocating that many bytes of memory. Okay, and if I think that returns, what does heap alloc return if it fails? Probably 0. Heap alloc. Return value, if the function fails and you have not specified except generate exceptions, the return value is null. All right, so if heap alloc equals null, then do we call, does it tell us to call get last error? No, I don't think you can't call get last error. If the function fails, it does not call set last error. An application cannot call get last error for this particular function. So we are just going to go error equals error memory, error not enough memory. Ah, shoot. Not enough memory. Go to exit. Okay, so now we have our memory. So we simply need to fill it with the contents of the file. Memcopy, we'll do memcopy s. Destination shall be game bitmap dot memory. Oh, and notice how I did a dot there, and then when I used tab to autocomplete it, it turned it into a arrow. This is one of the worst parts of C. If you're working with a pointer, then you're going to be using arrows. If you're working with a data structure directly, then you're going to be using dots. But I think no matter how many years you work with the C programming language, that will never quite catch on, and you'll never remember exactly which one you're supposed to use at all times, whether it be a period or an arrow. It's just, you have to just kind of like whichever one the compiler accepts. Anyway, so let's go back to memcopy. The destination size, well, we already know the size. It's going to be this big, right? And then the source will be no, this doesn't work for me. This does not work for me. Not yet. Not memcopy. I think maybe I should just use read file to read it directly from the file into memory. Let's try that. File handle. Let's use our buffer again. Game bitmap memory. Number of bytes to read, which is our BI size image, and then we'll reuse our same number of bytes read variable. We don't need overlapped. If this read file operation results in 0, then we know that we have failed. And we shall go to exit. At this point, I believe we are done. I believe this is it. We have now populated this thing with memory, except we failed. What did we do wrong? Wait. There we go. And just for completeness sake, let's set a breakpoint here and go look at it. If I go now to locals, we have our game bitmap. We have our memory. That doesn't look right to me. Oh. Okay, hang on. We forgot to move our file cursor to the beginning of the memory. Where are you? Oh, our pixel data offset. Did we already move? Offset. Okay, set file pointer. We need to zoom ahead to the beginning of our pixel data offset. Okay, now let's see if we can store it in here. Okay, hang on. Let's put a breakpoint right here. Oh, I just messed this all up. Okay, so what you're supposed to do is I was supposed to assign the value of game bitmap dot memory. See, heap alloc returns a pointer to memory, right? Which I need to assign to my game bitmap memory. What I was doing earlier is I was essentially just reading 1024 bytes of the file and assigning the first 4 bytes directly to this pointer, which makes no sense, and which is why it crashed and produced unpredictable results. So yeah, so I think this is more like what I need to do. Yep. Game bitmap. Game bitmap memory. Why is that not doing what I think it's supposed to be doing? What is going on here? Why is memory still 0? Of course that doesn't work. There, finally. It was all because my parentheses, I had some misplaced parentheses. I was missing some parentheses, and that was causing the error. But now you can see that game bitmap memory does in fact contain a valid user mode pointer. So that's our kilobyte of memory basically. And now if I click on copy value and go look at my memory, which is like Windows memory 1. Look over here, enter in the address of our game bitmap memory. What do we have except for a pixel perfect representation of what used to be in the file and is now in memory in our game bitmap? Remember, this is like BGRA, so that's our transparent pixel. And then as you can see, after a few pixels in, we start getting into colors. So yeah. Okay, so our load 32-bit bitmap function is complete at this point. So the next step is we need to go back to render frame graphics, and I believe what we need to do is we need to make a new function called maybe something like draw hero or draw player, and we need to basically blit that bitmap which we just loaded into memory onto the screen. But we're going to have to wait until next time because I'm way over time tonight. So that's too bad. I have to wait until till Wednesday. So anyway, thank you as always. Thank you for watching. Please do like and subscribe to the video, to the channel. If you have any comments or questions, please leave your comments on the video. I will address them in a future episode. In the meantime, don't forget that there is a GitHub repository which you can use to follow along. I keep it updated in step with these episodes. And that's all for today. So until next time, have a good weekend.